So, in the middle of working on my Heathkit IB102 frequency scaler, this thing shows up in the mail. Interestingly enough, a lot of sources say that Heathkit is now based in Fargo, North Dakota. But this says it's coming from Ottsville, Pennsylvania. I'm not really sure which information to believe. It seems unlikely they have more than one location. Maybe that's the headquarters. I don't know. Seems like a small company wouldn't have multiple locations. Anyway, I really held off on buying this thing from the modern Heathkit company because I just didn't believe it would be very satisfying or very good or as well designed as the classic stuff usually was. But it kept bugging me. I said I really should give them a try. And other than some bits and pieces, they really only have a couple of kits at this time in 2024, and that's a really crappy AM radio. It looks nice, but it has no calibration, so you don't know what station you're tuning in. You just have to twiddle the knob until you hear something you like. Apparently, from everything that I can learn about it. And there's supposedly, or so-called, most reliable clock, which follows up most accurate clock, most whatever clock that some of the names that Heathkit gave clocks in the past. And I've looked at Fran Blanche's video where she takes forever to build one of these, and that's her style. That's fine, it's her channel. She sits there and has you watch soldering every pad. I like to make long videos if there's a reason for it, but I don't want to drag my viewers through that much tedium. So I'm just going to build this thing, relay my experiences with it, and maybe I'll have a different take than Fran and some other people who've posted videos or other reviews. Maybe it'll be exactly the same thing. I'm more concerned about whether it's really a reliable product. There are hints of things saying that the power supply is poorly designed, that it sucks the batteries instead of just using them when the power's off, or that it uses them up because it's trying to run the LEDs at full brightness off the batteries instead of just maintaining the time. You know, there's a number of things like that. Maybe I'll learn more. Maybe this will be the last thing I buy from the modern Heathkit company. Maybe I'll start singing their praises. Who knows? Alright. I've been sitting on this product for quite a long time. It's the new version of Heathkit, their GC-1006 or GC-1006, so-called most reliable clock. Now, this is not a new product. They've had this out for a number of years, I believe, and there's been several people making these things on YouTube, so I'm hardly the first one. This is not something brand new that nobody else has done, but I'm hoping to put my own spin on it for people who watch my many YouTube videos on vintage Heathkits and a recent build where I bought a unbuilt kit and built it in a video. So I'm going to do the same treatment here for this most reliable clock. Alright, let's open this up. So, it says, "Congratulations, you have a first production run Heathkit GC-1006 most reliable clock kit. Do not open any kit envelopes yet. The assembly manual will tell you what to unpack and when to unpack it. Your manual is personal to you. It has been customized for you and contains your personal product and account access data. Be sure not to share it with others. It contains your private data. To start your adventure, take out the manual and turn to page 4. Heathkit uses environmentally friendly packing and parts. All the packing materials in the kit are recyclable or reusable. Also, all available components are ROHS, that's lead-free, including solder and wire. But don't recycle the paper yet. Some components are packed loose in paper. Please wait until you have the kit built before recycling the shipping materials. I'm not sure I'm going to use the lead-free solder. That stuff sucks. There's a letter here from Andy, the president, and the Heathkit team. I'm not sure there is a Heathkit team from everything I've heard and read. It may just be one guy, but you know, there's it's hard to believe they have a whole ton of product sales, especially when they only really have one proper kit, and that's this product, and it's been out for some years, I believe, and it's like they're still shipping the first production run according to the label. So, you know, how many employees can they sustain on that? That's why I doubt there's a team. This is another instantly historic Heathkit. Its predecessor over 30 years ago, the Heathkit GC-1005 clock kit, was among our most popular kits. We had both followed and improved on tradition in the GC-1006. Your most reliable clock is our own special patent-pending design using a microprocessor containing custom Heathkit firmware to provide a wake-up alarm, an integrated 10-minute perpetual timer snooze function, a one-button experience thoughtfully designed for everyday use, and the ability to keep running and reliably offer all clock functions for up to a month if the electrical power fails. Now, I've watched other videos on this product, and I don't think there's anything patentable in here. Everybody and their second cousin does microprocessor-based clocks these days, and having an alarm and having none of that's patentable. I don't know if they actually got a patent or if that's just marketing BS. You will find that the manual meets and exceeds all of our historic Heathkit standards for assembly instructions in every detail. We've also added modern improvements. One is customization. Your kit manual is personalized just for you. Please look in your manual for your personal login account information for your personal product page. It provides you with continuing personal product updates, tips, hints, kinks, upgrade and accessory information, tech support, contact data, and more. You'll want to check your personal product page, which is all marked trademark. Whoop-de-doo. I wish they would concentrate on making new kits instead of worrying about stuff like that on the web, and occasionally thereafter for new features and information of interest to you. If you need to contact us about your kit order, email is most effective. If you do contact us, please mention your sales order number or your product serial number in the email subject. Anyway, so I'm skeptical of some of this. It's, I think, misleading, but doesn't really have anything directly to do with the kit itself. So there's the manual. It looks like a decent manual. They're using the old this is so PC, it's irritating. This is the classic Heathkit illustration with the father you know, swiping the screwdriver away from the kid who's trying to build a radio. But they've substituted a girl instead of the boy who's building it. And that's all well and good, but the artwork design isn't really the same as the man. It's, you know, somebody made a good effort, but it doesn't really look quite like the same thing. And it shows one of the current Heathkit radios instead of the classic ones that are in the original illustration. Although it's interesting that the components that are on the bench before them look more like those for a vacuum tube radio with a big metal chassis and all that, so that's kind of silly. They would have been better off just sticking with the original illustration. So I'll do a separate run through the manual, but I'll do that later on in the video. So apparently the so-called personal product page is something on the Heathkit website, not part of the manual. However, the only place I found after about 3 passes through this manual page by page that's been personalized is inside page 16, where there is a section where it mentions an access code and a password and a URL. So there's that. And I should mention that I purchased this kit early in 2024, but the copyright dates on the manual start in 2016. So, you know, this kit is already about 8 years old at the time I bought it. And this is, you know, first production run according to what it says inside the box. So this kit's been sitting on their shelf, first production run, for about 8 years. That's not very encouraging for how many they've sold. Of course, I don't know how many they made in the first production run, but I don't imagine it was like 10,000 of them or anything. My guess is that it was maybe in hundreds. Maybe they're making these things as they're ordered, or in very small batches, and they just haven't updated any of the labels or things in the letter. That could be the case. Anyway, I doubt they're cranking these things out in huge quantities. I do think it's kind of silly to put this personal information on page 16. It would seem like it would make a whole lot more sense to, you know, put it like inside the front cover, inside the back cover on page 2, or someplace logical. This page is not referenced in the table of contents, so if you're looking for that information, you can't find it from the table of contents. I just found it after flipping through the pages and looking for it and missing it until, you know, the third or fourth pass. Then I finally spotted this little area that hardly jumps out at you. It looks like fine print having to do with the parts identification drawings. So I decided to go to the stipulated Heathkit website and look at my personal product page. Well, I certainly got to the login page following the URL that was given here, but it asks for a username, which I never created and have not been provided. I kept all the emails associated with this order from Heathkit, and there was nothing about a username. There's an access code given here, which was not asked for when I was trying to log in. I tried putting in the access code instead of username, and that didn't work. And I tried around. I must have spent half an hour farting around with it, and nothing worked. So, the hell with them. I'm going to just proceed with that without the nonsense of the personal product page. The other contents of the box: a power transformer, which from the weight would seem to be a linear power pack, a wall wart. It's a US Robotics AC adapter, 120 volts AC, 60 hertz. Yeah, 9 volts AC output. So this is not even a power supply, it's just a transformer in a wall wart package. US Robotics, I haven't seen that name in like 30 years, 35 years. They used to make like modems, dial-up modems and things like that. I'm surprised to still see something on a new product that has that name. Wow. But yeah, this is like, when's the last time anybody... Well, the only reason I can think of for using just a transformer wall wart instead of a switching power supply type is if they're using the frequency of the line voltage as the synchronizing signal for the clock. In other words, the time base, which might be the case. But most modern clocks don't do that. They'll use a crystal oscillator, which actually in the long run is not as accurate as the power line frequency, at least in places like Europe and North America. Other countries it may be a little sloppier. Parts of the world might have sloppier control of their power line frequencies. I don't know. But okay, that may be a legitimate reason for having just a simple a transformer power supply. There's a envelope with ICs, an envelope with electronic components, envelope with displays and speaker, tools and hardware, and panels and PCB. 3 of the envelopes have an OR suffix on their parts bag part number, and according to the manual, that means that I have apparently selected the orange display and LEDs option. I don't remember doing that, but maybe I did. According to this, you'd also have a choice of green, in which case those suffixes would be GR instead of OR. Alright, here are the contents of the tools and hardware bag, and I'm supposed to take an inventory of those now. All parts that are supposed to be in that bag were in the bag. And the illustrations are helpful. And even though it said don't unpack everything all at once, it seems like it's having me just go through the bags one after another and checking their components. So that's fine. I thought they might have me do a partial assembly and then use all the parts from that bag and then so on, but it's not organized that way. The bags are organized more towards type of components, not per assembly step. So I put most of the components back in the bag, except for like some of the little nuts and bolts and things, which I pushed to the side. So now I'm going to undo the electronic components bag and check the contents. Okay, there are the contents of that bag. 2 different sizes of yellow or amber LED, some resistors, electrolytic capacitor, 3-terminal device, which is probably a voltage regulator, 5 tactile push buttons with long shafts on them, 3 small electrolytic capacitors, a couple of small ceramic capacitors, 3-terminal device, looks like a transistor, 3 little plastic light pipe looking things, a push button cap, a piece of what looks like white shrink tube, a power jack banana type, heat sink probably for this, small diode, 4 bigger diodes, and a bunch more resistors, and a little bag of solder, which is apparently the lead-free solder that was promised in the manual. Okay, in the electronic components bag, it's missing a 47K resistor quantity 1 and a multi-color ribbon cable 8 inches not in there, and where there should be 4 little LED light pipes, there are only 3, so that's 3 hits right out of one parts bag that doesn't really have that many parts in it. That is way bad. Looking at the displays and speaker bag, okay, there are the contents of that bag, all put on an anti-static foam block. And those parts were all in the bag. Looking in the IC's parts bag, and there are those, that's the contents of that bag. 2 ICs on the anti-static foam. So those components match the parts list. And finally, the panels and PCB bag. And there are the contents of that bag. 2 wooden side panels, a circuit board. It's actually 2 circuit boards with a scribe line down the middle to break it from one board into 2 boards. What's apparently the bottom panel, or maybe the, I don't know what that is, top panel, bottom panel. I'm guessing it's the bottom panel of the kit. This is probably the top panel with these 2 glued on flanges on it. Big piece of clear acrylic. Another piece of clear acrylic with backing paper or, anti-scratch paper on them. So this is with the red. So this one has the red filter material on it. And that's appropriate because I have the reddish display option. And then the label for the back panel with the switches and the power jack. And all those parts are present. Once again, I'm going to check to see if there's any other updates, and I'm also going to ask Heath to send me the missing parts, even though they are ones that I think I could supply pretty easily out of my stock of junk. I think I have some ribbon cable, although maybe not the same color as what they would have provided. And I certainly have a resistor, but I'm going to see what kind of experience I have requesting parts from them, if they are reachable in the first place, if they respond promptly, if they ship promptly. We'll see. Alright, well, I tried it again. This is the 4th or 5th time I've tried it today, and instead of getting some sort of an error message, I actually got my personal product page. So it did work. I don't know what the glitch was. This page was last updated on February 8th, 2023. So does that mean they generated the page before I even bought the kit? Maybe. So what's on here? Important manual updates. New features, frequently asked questions, such as what is the right temperature for the soldering iron, calibrating the most reliable clock, internationalization accessories for the clock. This looks like the wrong capacitors. How do I tell which capacitor end is the positive negative? Identifying capacitors. Why do I have 2 spare resistors? And how to change the alarm volume on the clock. Altering the brightness of the clock display. How can I extend the life of my clock batteries? Why does my clock seem to gain or lose a few seconds every day? Contacting Heathkit. So there's links for all those things. So manual updates. There's a bunch of things where you have to go in and make corrections to the manual. We already have new content in preparation for you. Please check back here again after you build your kit. Yeah, so I'll read this and I'll make updates to my manual. So I marked up my manual with all the errata and addendums from the personal product web page. And I sent off a couple of emails, one with notifications of errors I found, and then the other email with the parts that were missing. And also included a critique of issues such as the serial number being variously called, the serial number, the user ID, and what was the third thing they called it? The access code. So the same number is used over and over, and actually it's a big part of the personal product page URL. So that number, I actually created a text document on my computer under the folder for this project, and just put that number in there, because it's a pain in the ass to type it over and over if you have to communicate with Heath. So I just thought I'll put it in there so I can copy and paste it going forwards, and we'll see what they do. But I was also reading through the about 4 pages of questions and answers, FAQs, other information that were on there, and boy, is there a lot of hooey in there. I tell you, it's they say, well, the clock is very sensitive, or it's sensitive to power line noise that will cause it to be inaccurate. but that's the power company's fault, or you have some Chinese made, offshore made, or whatever they call it, you know, equipment that's making a lot of noise. So they suggest that because they're suggesting it, that it's a big enough problem that they would bring it up in the first place. But then they go through and say some ridiculously low percentage of customers have reported the problem. And I'm thinking, well, how would they know unless each and every customer reports, which I doubt that happens. Probably almost no customers report. And if that's the case, how can they be quoting a, you know, like 0.00% or whatever it was statistic? You know, that doesn't make sense. I very much doubt they've sold enough of these to accumulate anywhere near enough data to have such precise statistics. So, what was it Mark Twain who said there's 3 kinds of lies, damn lies, and statistics? And the other one, which is 69.3% of all statistics are made up on the spot. I think that applies. It's almost like delusions of grandeur. That why not just say we haven't had many complaints about issues due to power line frequency. Instead, it's this long-winded thing that by its existence suggests that there's a problem, an overly great susceptibility, and then turning it on its head and making it sound like, well, we've done these extensive surveys and, you know, only a very tiny number of customers have a problem with it. Doesn't add up to me. I think it's BS. There is a error here on the step-by-step assembly instructions talking about how this is a single-sided circuit board. It's very clearly a double-sided board with pads and foils on both sides. That's kind of sloppy. It says if there are paper ends on the parts, for example, a bunch of resistors that have the paper strips on the leads, they want you to recycle that. Well, you clip the leads off the paper, and recyclers don't want you to be putting in paper with little bits of metal embedded in it. That, jeez. I just got an email from Heathkit responding to my email about the missing parts, and it's an automated thing. It's not written by a live person, but it has the usual BS that every customer service related message in the world now seems to have, that they are experiencing an extremely high period of, you know, it's like, oh, come on. That's just an excuse for not having adequate manning and having people being lazy about returning calls and emails. You know, you either have people who aren't working hard enough, or you're understaffed or something. But, you know, I hope they don't delay the parts. If they do, I'm just going to go ahead and use my own stuff to finish this, except for the light pipes, which I won't be able to source. They'll have to get that to me, but I'm not going to sit around waiting for them if they're going to be slow in responding. Okay, the first part, a 10K resistor. And as expected, my 6040 tin lead solder works just fine with these boards. Don't need to use that lead-free garbage. So most of the resistors have been soldered to the board now. There are still 2 unaccounted for. Some of those may be for alternate volume or brightness, you know, hacks later on. I'm not sure yet. I did not read it ahead in the manual. Alright, diodes and capacitors, except for this little diode here, which has no markings that I can discern, even with a jeweler's loupe. It looks like somebody tried to mark it, but just did a crappy job of it. And since I can't identify the part with the bill of material, and knowing that small parts like this can get mixed up, I looked up the part number from the manual, and I should note that this is the first Heathkit manual where in the parts identification chart it does not list the actual values. For example, in a traditional Heathkit manual, if there's a Zener diode, it would tell you what the Zener voltage was. On here it tells you what the part number is, 1N whatever it is, but it doesn't tell you what the Zener voltage is. So I looked up the data sheet, and it's supposed to be a 6.2 volt part. So I popped it into my peak Zener tester, and it was having problems with it. So I built a little test fixture with a resistance decade box and my bench power supply and the Zener, and just brought it up very carefully. It's a 500 milliwatt part, so it's a half a watt part, so it's small, but it can handle decent dissipation. I didn't bring it anywhere near there, but I was still giving it the current that the data sheet suggested would be appropriate for it to get the nominal Zener voltage. As you may or may not know, for a given Zener diode, the actual voltage it regulates to or develops across it varies somewhat depending on the current through it. So if you want to get the optimal voltage, you want to adjust the components around it so that you get the ideal current. So I arranged for that, and I was getting 5 volts. So I don't know what this part is, but it's not a 6.2 volt Zener. So another email to Heathkit is coming up, but I did assemble all the other diodes, which is just 1N4002s, onto the board. Next up, I have to cut these 18 pin sockets in half to make SIP sockets from the dip sockets. They suggest doing those with a diagonal cutter, but I think that'll make kind of a rough finish, so I'm gonna cut them with a better tool. And now that work is done, the next step is to plug these into the display modules and then solder the sockets into the circuit board with the display modules holding them in proper alignment. Like this. On the page that instructs me to solder the socket-equipped LED modules to the circuit board, none of the steps actually talk about which way it should be oriented. Now granted, if it gets oriented backwards, the module can be unplugged from the socket and plugged in the other way around. But there is a note up here in italics about making sure the decimal point is towards the middle of the circuit board to avoid the numbers appearing upside down. And then if you discover you've got it backwards, just unplug it and flip it. This isn't necessarily a bad way to do it, but if they'd followed the usual Heathkit approach to describing things clearly, they wouldn't make it a footnote or a sidebar. They would actually put it in the checked instructions. That's the thing you're following, and to have it over here risks somebody missing that. Again, it's not the end of the world if they do. It's just a deviation from the traditional scheme that Heathkit used. Alright, the LED displays are on the circuit board. And the two IC sockets have now been soldered to the board. And I want to note here that normally good practice is that you solder lowest components first and then build up. And actually, in my experience and from training aids I've studied and so on, almost everybody recommends that you put in all the IC sockets first and then start putting in leaded components. That way, if you assuming you're using all the same model of socket, they're all the same height, and you can populate the board and then just lay it down flat and solder them all. Heathkit has decided to wait to put these in until after tall things like the displays are in there, and even their sockets are taller than the IC sockets, so even removing the LED modules would still leave problems, because then the capacitors are the next tallest thing. And so what they recommend doing is sticking the sockets through and then bending over the 4 corner leads. That's bad practice, I'm sorry. They should know better. If they just had the assembly order proper, they wouldn't have had that kludgy thing in the instructions. So next up is installing the ICs, and they go through about 1 page of cautions about how to handle them to prevent damage due to static electricity, and that's a good thing. I'm not sure that these particular ICs are really all that sensitive. Most ICs are not. You know, they have built-in protection diodes on all the pins and things like that, but they're still being cautious, and that's okay. Alright, the 2 ICs have been installed. The next step is to mount the 3-terminal linear voltage regulator, the 7805, to the heatsink with the included hardware, and solder it to the circuit board. There's a couple problems with this. First off, the instructions say to use a 632 panhead screw. Okay, there is no 632 panhead screw mentioned or included in the parts list. There are some 632 screws which are much longer than needed for mounting an IC like this to a heatsink, and I suspect those are used for something else. There are no other 632 screws in the kit, so that's one problem. They have a parts identification and instruction accuracy issue. The second issue with that is that 632 screws do not fit through heatsinks like this. They're almost universally sized for 532, or number 5 at least, hardware. You can't put a number 6 screw through them unless you force it in and make it create its own threads. It just doesn't go in. Now I happen to have here a 540 screw and nut, and these are exactly the right size. It's obviously what the heat sinks are designed for. I don't know why Heathkit would include or recommend using hardware that doesn't fit the other hardware. So I'm just going to solve this problem by ignoring the 632 nut and lock washer. This is actually a 632 button head hex drive screw from my own stock that initially I grabbed to use so I don't risk using up one of those that I shouldn't be using. Plus they're not really pan heads exactly, I don't know. But I'm just going to use a 540 screw and nut from my own stock. The old Heathkit, I think virtually always, if not always, recommended putting some silicone grease or heatsink compound on the back of any component that was going to be mounted to a heatsink. This Heathkit doesn't include any such stuff, nor do they recommend or mention the use thereof, but I'm going to do it just because it's good practice and consistent with the Heathkit of old. Heathkit has provided a heatsink with solder tabs on it, but the circuit board is not set up for solder tabs, so the instructions recommend just tearing those off using a pliers. Well, it turns out they don't want me to solder it to the board yet. They want me to set it aside for later, so I'm going to do that. Well, the next step is to use the LED light pipes. And as I already mentioned, I only have 3 and I need 4, so I'm kind of stuck on this until Heathkit comes up with the missing part. I just sent them an email regarding the issue with the parts identification on the number 632 panhead screw, and also that it's not the right size for the heatsink. I do acknowledge, and I did acknowledge in my email, that it's kind of half-assed described in here. They say screwing the 632 screw through the heatsink shield, then through the regulator tab. So that isn't very clear. Heathkit would have been clearer in the old days if they had even done something that kludgy. It doesn't say force thread the screw so that its threads cut a hole in the heatsink, which is what you're really being told to do here. I think a lot of newbies, especially builders, would assume the screw should just go through the hole, and that's what they mean by screwing it through there, or that it's tapped for number 632. This is a real kludgy thing on Heath's part, and I can't think of any excuse for it. 540 hardware is hardly rare or hard to locate or find. They're probably not even going to answer any of my emails. I'm not sure anybody's alive there. They have not responded to my, missing parts emails from yesterday. Well, it's been a week since I sent Heathkit my email about missing parts, and other than the automated response that came right away that said they were busy and would get to me when they got to me, I consider them to be deadbeats in this regard, and I'm not going to expect that they're actually going to get back to me and provide the missing parts. I can certainly deal with a missing resistor. I can figure out hardware issues. It's really the light pipes. These 3 little light pipes I have. I'm not really sure what their purpose is. I've read the manual, the page that deals with these, several times, and I don't think I'm missing any information. It seems like the goal is to get a more even face, instead of looking at the end of an LED, and these LEDs are used for the colons between every 2 digits of the display. Maybe the light pipe gives it a smoother, more even look. And I have the understanding that the leads on the LEDs are plenty long enough to make up any difference in height. But I think if you put a light pipe and an LED together, it's not much difference in overall length than the distance from the circuit board up to the front of the display. So the light pipes might also be a means to not have the LED standing up on its leads for so long. I'm not really sure what the goal is. So I think what I'm going to do is make one of these up according to the instructions and see what it looks like. And if the goal is just to get a nice, evenly diffused circle of light or disk of light, then I think I can do without the light pipes by just sanding the dome off of the LED so it's flat, and then it'll be a matte finish, and it should light up very evenly. So if that experiment works out the way I think it will, then I can dispense with the light pipes and just do it my way. Okay, using the pliers according to the instructions to make a stop inside a piece of 3/8 inch long shrink tubing, I've put one of the light pipes in there until it's flush at the end. It can't slide any further down because of the pliers, and then use the side of my soldering iron to shrink just the end of the shrink tube where it holds the light pipe in place. And now I'm supposed to stick the LED in until it's touching the back of the light pipe and then shrink that. Okay, that seemed to have come out just about the way it was described. The black shrink tubing also works to prevent any light from escaping sideways out of the LED, which would otherwise possibly pollute the way the display looks, make it look more diffuse than it should be. So that's a reason for the light pipe. And with the tubing cut to the specified length, it just comes to the back of the LED and maybe just a hair beyond it. So I think that all worked out pretty much as planned. Now I'm going to do my test. So there's the way the LED looks. It shows up terribly on the camera. It actually has a nice reddish orange look. It's pretty evenly diffused when look at it straight on. And of course nothing comes out the side. So that's obviously the goal. I'm not sure if it really looks any different from the end. It may have just a touch more of a hot spot in the middle of it. And certainly there's light coming out of the side. But, Alright, I've made up a little test fixture here. And I can look at the ends of them. And so a couple things I notice. And again, the camera lies a little bit here, but the point of light seems to be a little bigger when it's diffused. Part of that's just because, due to the length of the light pipe, this one is just a little closer to the camera lens, so it's going to look a little bigger. To my naked eye from out here, they're pretty much indistinguishable. I think this is slightly more diffused than this one. I think there's a lot of merit to having the black shrink tube around the LED so no light goes out sideways and it's only emitted from the front. But I think that can be achieved by sanding down the end of the round LED just a little bit and then putting shrink tube around the rest of it. So I'm going to take a chance that that won't kill the LED and I'll get a usable result. I'm going to try that out. Alright, so it should be apparent here that I've sanded off most of the round part of the LED, and it now has a nice diffused end on it, like a piece of a matte surface, and I'm going to try it in comparison with the other one. Well, I'm not in love with the way that looks, actually. I think the dome is part of an optical, I think it's basically part of a lens, and with the dome sanded away, I get more of a hot spot. It doesn't look nearly as nice as the diffused one. So I don't think I'm going to go that way. Probably better just to use the LEDs with shrink tube on them and do something so that the shrink tube doesn't collapse in over the rounded end. That'll be the trick. Well, you can even see the difference here. This is another LED I pulled out of my parts bin. It's an amber LED, but it's definitely yellow compared to the orangish color of the ones that were provided with the kit. So it won't match the presumably amber colored LEDs there like it should. So I need to see what I can get in the way of T1 size LEDs, diffused type, and with an amber or orangish color instead of a yellow color. Well, I tried to put a light pipe on my sawed off LED and yeah, it doesn't work as well. It's definitely looks dimmer. I definitely messed up the optics of the LED by grinding it off like that in my experiment. So I do need to go get some, like an evenly matched set of these. If Heathkit was responsive, I could probably just say, hey, I've managed to mangle one of the LEDs, can you send me a replacement? But I don't want to wait indefinitely for them to respond, which I think is probably what I'd have to do. Alright, my DigiKey order came in. I have some new LEDs. These are diffused orange LEDs. I hope that they're comparable to the color of the original LEDs. I'll make a comparison before I install them. These are a Broadcom part. It's generic, so multiple makers make them, but I'm using the Broadcom ones. And they're using the old Dialite part number, HLMP-K401. And they're a T1 size. Look like that. I got the Dialite, or not the Dialite, but the Bivar light pipes. It's kind of interesting. They changed their they changed their tags here. They don't say the brand name anymore, that anywhere I can see. Oh no, way down the corner, Bivar. So the Bivar part number is PLP-C3-5mm. That's I think the diameter. Anyway, so there's that. And since Heathkit did not furnish the required ribbon cable for this kit, I've got this 3M ribbon cable. I just picked semi at random from the DigiKey offerings. So there's the original Heathkit supplied light pipe, and here's the Bivar one. Look like they're approximately the same dimensions. The Heathkit one does not seem to have a wide section on the end, whereas the Bivar one definitely does, but it's almost not discernible. It's a tiny, tiny little widening at the right end of it here in the picture, so you can drive it into a hole in a panel and it'll sort of wedge in there. I don't think I need to remove that. I think it'll be just fine the way it is. So the camera isn't going to give a good indication of the actual color because of its problems with certain wavelengths of red on the image sensor, but to my eye these are nearly identical colors. There is a slight difference in the color. This one from Heathkit is slightly more reddish, but they're very, very close, so I think it'll be fine. So on the right is one of the Bivar light pipes with the new LED, and on the left is one of the Heathkit light pipes with their LED. So yeah, really a good match. Works just fine. So I'm going to make 4 of these up, because using the Heathkit LEDs I cannot get a set of 4, and I need them all to have the same look. Okay, the 4 matching light piped LEDs. Looks like I've got a little trimming to do on that one of them yet, but I've tested these all and they all work. I wanted to make sure I tested them before I soldered them into the circuit board. The next step is to solder the 4 colon LEDs into the circuit board, and I have to say that although I'm not thrilled with some aspects of this kit design, somebody put in the extra work or paid attention enough to stagger the LEDs. You can see the top one, LED 3, is a little bit to the right of the one at LED 4, and that is to match the right slanting digits on the 7-segment LEDs, so you don't have a vertical colon next to slanting digits. The LEDs are inserted into the circuit board. It actually says to do one at a time, but I put them all through together. And they hang by gravity down until the fronts of the LED light pipes rest flat on the same surface that the 7-segment LEDs are resting flat on. and then just one lead is soldered for each LED. And this allows them to be viewed from the front then without them falling out, and tweak their position so they're standing up straight on the circuit board, and then solder the other lead. So I've got them visually lined up as best as I can. I put a straight edge ruler across the inside edges of the 7 segments and tried to align the tops of the LEDs with that, and similarly along the bottom, and then eyeball it for the proper slope left to right. I think I've got it pretty good. It doesn't necessarily look that way on the camera, but when I look at it with my eyes it looks better. Next is the so-called light dependent resistor. It's just a photocell, and it goes right here on the circuit board using the same technique of getting it level and even with the fronts of the 7-segment LEDs. And then the 2 larger T1 3/4 LEDs go in at positions LED 1 and LED 2. That's over here on the left side of the board. These do not get a light pipe. But they get installed in the same manner to get them flush with the front. The next bit is something I've never seen done before. It's a first for me. We have to create a light shield for these 2 larger LEDs, and we do it out of this white heat shrink tubing, of which 2 inches is provided. They want to have the builder hold it vertically, and it comes kind of flat. I've been trying to squeeze it into a rounder shape for this step. And you kind of wave the soldering iron shaft around the end really close while turning it and try to get it soft, and then when the edge starts curling inwards, then immediately jab it over one of the large LEDs, and that'll form it to the proper shape and size, and then remove it from the LED and cut about 1/3 of an inch, which isn't the way rulers are graduated, so they give you 8 millimeters. Cut it to 8 millimeters, and then jam it down over the LED, and then do the same thing for the other LED. So it ends up with a light shield that doesn't touch the LED except down by the base. So I've had it curl inwards. I pushed it over the end of the LED, just past the dome part, and that's what I end up with. And this is what you end up with. It slid down to the wider spot on the LED, so it just sits there, and because the end has been curled in, it won't slip past that, and then it provides this light shield around the LED, and the end is approximately even with the display. I actually cut this one just a little short. It was too long. I tried to cut it shorter and went a little bit overboard, but I think it'll still work out okay. Okay, the 2 light shields are on there. The downside to this is that these tubes, these shrink tubes, come flat, and they want to return to that shape unless they're shrunk. So I think Heathkit wants these to be round and surround the LED without quite touching it. And this one's definitely oval. I think it's going to make it into a really ugly looking shape. Alright, there's the circuit board assembly up to this point. Now push button switches and other things will be installed on the circuit board, including the heat sink and the regulator that's on the heat sink. Now here's a place where the instructions are not up to normal traditional Heathkit standards. It says to install this push button switch at this location, but it gives no guidance whatsoever on how to install it. So a person who doesn't know any better would put these into the holes like this, it seems like that's as far in as it goes, and the board is up above the, or the switch is up above the board, but in fact you have to push it down hard and then it snaps past the little detents on the 4 leads until it sits flat on the circuit board. And the instructions just say simply install a push button switch at S5 on the display board. Doesn't say push it all the way down until it's laying flat on the board. That's a screw up, and the original Heathkit probably would not have let that one slide. So whoever wrote this page of the manual just seems to have been in lazy mode. All of a sudden they're getting tired of writing clear instructions and just starting to, you know, leave out details. So it says install the 7805 regulator with heatsink at VR1. Doesn't say anything about how to install it. The original Heathkit would have told you, it's shown you a picture of it. So, for example, the 3 leads of the regulator are straight, but the hole pattern on the circuit board has the middle lead tilted out. It does not say how far down to install it. One might assume it's until the heatsink bottoms out, and that may be the case, but it should say that. That is something Heathkit did. They made sure the instructions were unambiguous and clear as could be. So, since Heathkit does not in any way address how to shape the leads or form the leads, I've just tilted the middle lead forward right where it comes out of the plastic body, and then where it goes from the wider tab to the actual lead, that's the point where I folded it straight back down again, so it goes like that. And doing that way worked just fine. The leads went in very easily. Next up, the so-called alarm annunciator and the 4 remaining push-button switches get installed on the back side of the lower part of the board in 1, 2, 3, 4, 5 positions. At least the instructions here do underline the word backside of the board, but they don't picture it, which they should have done. The original Heathkit would have definitely shown a picture of that to accentuate it. Here's another possible mistake. Not really sure if it is a mistake or not. This alarm annunciator is marked with a plus on this lead, suggesting that polarity is important. The circuit board is not marked with a plus, although I've marked it with a crude Sharpie plus there, but it originally does not have any markings for plus, and the instructions do not address polarity on it. So I'm not sure if it's important or not, but it does seem odd that the part would be marked with a plus if it's not important. So I'm going to install it that way. And the schematic diagram in the back of the manual shows it as a polarized part with plus and minus leads. So Heathkit could have done a much better job on this, at least to alleviate confusion or concern, even if it doesn't really matter which way it goes in. So the anode of this diode goes to the top pad, and the cathode goes to the other pad, so leads go straight across, or foils go straight across. And the schematic shows that the plus side of the annunciator goes to the cathode side of the diode, so it's definitely the bottom pad here is the one that should have the plus. So another place where they got lazy with the instructions is they don't instruct the builder to put the annunciator on the back of the board, push it up against the board, solder one lead, and then while holding pressure on the component, soften that lead again with the soldering iron and make sure it snaps flush against the board. It probably won't unless it's done that way, and then only then solder the other lead. That's not mentioned at all, but that is the correct way to solder something like this that needs to fit up flush against the board. Alright, so the next step is the moment of truth. I've probably mentioned in this video before that I was wondering why they didn't have the two manufactured as one piece, but yet scored for separation, the two board halves. Why they didn't have the builder just separate those right away and then build them up. It would be more difficult to do it once all the components are installed, but I am at that point in the instructions where it says to do that. It says to hold the board this way with thumb on the display on the left side, and between thumb and four-fingers with the thumbs on the top and the fingers are on the back, and similarly for the right hand side of the board. And then just gently push up from below. You will gently push up from below the board with your fingers and snap the two parts along the black line running down the middle between the Heathkit part number, between the two Heathkit part numbers. Firmly snap the boards apart, it says. I don't even know where to grab it. Yep, it does work that way. It does work. Feel as you're going to break something, and I actually bent the capacitor out of whack a little bit, but nothing really broke. So it does work to do it that way. It's not the end of the world. I'd heard other people saying that they could not get the boards apart that way, and it certainly felt like they weren't going to separate, but then finally I heard the sound of the fiberglass fibers starting to snap, and then it came apart pretty easily. So, although I don't endorse the way they're doing it, and I'd actually recommend people to build these in two halves and separate them in front, it does work the way they describe it in the manual. Okay, the ribbon cable has been soldered. It comes from the component or front side of the main circuit board and goes over to the rear or solder side of the display circuit board, and it's one-to-one, no wires crossing over or anything, except for the one that's called the violet wire. On my substitute cable it's not violet, and it's cut longer and it goes around to here to be close to the snooze button. I'm not sure why they couldn't run a foil across there, but this is the way they chose to do it. And I did see a couple other people comment that they couldn't get the wires through the holes. Now granted, I'm not using the official ribbon cable because it didn't come with it. I'm using, actually it's a old roll of Archer, which is Radio Shack 25 conductor ribbon cable that I've been using bits and pieces of for the last few decades. Still perfectly good, if maybe the insulation is just a little stiffer than it used to be. And I found that there was lots of leeway in the holes to fit the wire through. Now you're supposed to twist the wire, and if you twist it properly and then tin it properly without getting big globs of solder on it, the only glob of solder should be where you wipe the soldering iron tip down the length of the wire to towards the end of the wire, and then you'll get a little blob of solder there. Then you cut that off, and then what you have left is a nice evenly tinned wire that should fit through the hole. And even though I can't say for sure because maybe they use some really fat wire, but typically ribbon cable is not a very large gauge of wire. And I would suspect that the people who have trouble with that are probably just not very skilled at how to tin and prepare wires of this sort, but that's just my guess. Up next is the battery holder, and the leads need to be trimmed to 3 inches and prepared by stripping the insulation and tinning them with solder after being twisted. And then the red wire goes into the battery plus hole on the main circuit board, and the black wire goes into the battery minus hole on the main circuit board. Up next is getting 2 wires, and I'm supposed to use some lengths of ribbon cable that were peeled off the part I used for that, but I didn't do it that way, so I just got a little bit of 22 gauge stranded wire from my shop supplies. I didn't have gray, so I'm using blue instead, and the other one's black like the manual says, and that's for connecting up to the power jack. And there the two wires are soldered up to the power jack, being careful to not soldering anything to the middle terminal per the instructions. And now I put this aside because we start assembling the mechanical part of the kit. Alright, starting the assembly of the mechanical portion of the kit. In other words, the case. So the first piece I have to identify is the so-called front subpanel, which is a laser cut acrylic piece with protective paper on it. And looks like it goes that way, more or less. I've also located the 4 anchors, and I have to find 2 half-inch self-tapping screws. So just reading this page, it's pretty clear to me that by the time they got to this point in writing the manual, the person or persons who wrote it had just gotten tired and given up trying. It started out pretty good, and then the further I get into it, the more mistakes there are, just blatant mistakes, omissions, fewer and fewer diagrams and illustrations. They don't match up very clearly with the text. Things are said in the text without any pictures to help guide the builder in what the heck is being talked about. This is not a Heathkit manual here. This is a joke. You know, I've seen worse for sure, but this is a lame effort by the time we get to here. You know, they should have taken more time and cooled off and come back and started with more vigor, and instead of just getting lazy and sloppy with it like this. There's a small bag with 2 screws in it. They're self-tapping screws. One of them is a 440 thread, the other is a 632 thread. And those are supposed to be driven into the holes in these pieces here, which the manual calls anchors. They're 3D printed. They have 2 holes on the side and 1 hole on the end. The hole on the end is supposed to be tapped for 632, and then the 2 holes on the side are supposed to be tapped with 440. However, I'm going to be using a proper 440 and 632 tap with a tap handle, just because I think it'll be a little cleaner. It may not actually work better at the end of the day, but I'm going to do it that way. Okay, using 4 of the button head 440 stainless steel screws. They've been fed through the countersunk side of the front panel there and threaded into the 2 anchors, aligned like this, flush on a table, and then tightened both sides. Now the front panel graphic overlay will be affixed to the front panel subassembly. Well, I was just following the instructions because part of this video is about how well do the instructions work, and they didn't mention removing the paper. I thought, well, maybe they'll tell me just to tear it off or something, or, you know, leave this side. Well, you can't leave this side of it in place, but you know, maybe there will be something about that. But then there was actually an addendum which instructed the builder to peel off that paper front and rear before putting on the anchors. So I have to go back and do that. The instructions advise at this point to go over the front and rear of this acrylic plastic subpanel with, well, it just says a dry, non-abrasive cloth, and I used some Tech wipes, but I had a lot of fingerprints on there and it was just smearing it around, so I used a little bit of Zep streak-free glass cleaner. I was going to use just some isopropyl alcohol, but decided to use that instead. And the instructions also say to wipe the back side of the overlay, probably to get any dirt off of these areas, because it'll get trapped between this and the acrylic and you won't be able to clean it later, so that makes sense to clean it now. The technique for adhering the overlay is there's backing paper in two sections. About the left third of it can come off separately from the other 2/3, so that's peeled off first. I've got the edge of it here, and then the starting with the right side, which still has the backing paper on it, get that lined up and slowly roll it down until the left side is adhered, and then, assuming that's still looking good, then lift up the right side and peel off the backing paper there and roll it down from left to right. Okay, that went on pretty smoothly using the technique that's described. There is a protective film over the front of this which needs to be removed, but I'm not going to do that quite yet. Well, an addendum to the manual says to take off the protective plastic film, so I will do that now. There's this diffusion strip, which is sort of a frosty looking material, apparently adhesively stuck onto this wax paper backing. The instructions are really vague about this, and there's no diagram that shows about 6 steps in a row. The description just isn't real good. I've read it over several times, and I think I know what they mean to do or want me to do, but it's definitely not clearly written. Again, lazy and sloppy writing on the part of the authors of this manual. Not nearly as good as it was towards the front of the manual. Kind of once they got done with the step-by-step assembly of the circuit board, things started falling apart in terms of clarity of writing. But anyway, I'm supposed to cut this into 3 equal lengths, and then it doesn't say to remove the diffusion part from the backing paper, but I'm supposed to build up 3 layers. And I don't know how you could do that without removing the backing paper, but it doesn't include that as a step. So that's, one of the things I could have been much clearer about. So here's one of the diffusion strips removed from its backing paper, and I have to stick it on to the next one. Okay, I've done that. The lineup wasn't absolutely precise, so at the end of it I've got just a little bit of run out, but I think it'll be fine. Only a small area of this actually needs to be used for the diffusion. The rest is just a surrounding area. And a small bit of it is marked at 8 millimeters, and then that needs to be cut out and affixed over the behind the bell symbol, making sure it doesn't go so far that it'll touch the bell, which shouldn't be possible. Okay, there's the 3-layered diffusion strip over the bell symbol, which is for the alarm. And now I have to make a similar one to go over the moon symbol. And so that one's on there now too. And now a similar treatment's going to be given to the rear subpanel and its overlay. And its anchors. Inconsistency in terminology. This is ongoing. Some places call it the rear panel, other places call it the back panel. That kind of stuff goes on quite a lot here. Just, if you're trying to do these kinds of things and do them clearly, you pick terminology, then you stick with it throughout. And they fail to do that. Just makes it confusing sometimes. Back and rear might be simple, but there's other places that are less clear. The front subassembly is now used as a holder to elevate the back panel while working on it, or the rear panel. But the anchors are not put on yet. Alright, there's the rear overlay on the rear acrylic panel. I found that this was distorted a little bit. I could not line up all edges and still have the holes for the switches centered properly. So it was also wider at one end than the other, so there was going to be an overhang along the bottom. So I don't know what got screwed up there. I didn't measure it. I'm guessing that the 3M overlay is probably the more accurate of the two, but usually these laser cut pieces are pretty accurate. So you end up with some pretty severe misalignments like this. This is the hole for the annunciator to let the air pressure out, and there was no way that was going to be centered. Just no way. And you could see how far off it got with these mounting holes here, how far off they were. But that's with the label lining up along the edges. So I just went with the edges, except for where it overhanged a little bit, but again the label was wider than the acrylic. And then I got my X-Acto knife and did very delicate slicing maneuvers to make sure that the overlay did not block any of the laser cut holes, and make sure that that doesn't bind up the switch buttons. And you can't really tell that much, in context, that anything has happened there. Once it's, dark on the inside, you won't be able to, and the buttons are through the holes, you won't be able to see that that took place. Other places where there's a bit of a misalignment is around the hole for the power jack, and that again will be covered up by the bezel of the power jack. So I corrected for whatever anomaly was the cause of the alignment issues here, and I think it'll be okay. And then it's stuck through the cutout in the rear panel, and it comes out looking like that. So the anchors have been loosely screwed onto the back side of the rear panel, and the wires from the power jack have been soldered into the appropriate holes on the circuit board. By the way, this is an AC signal coming out of here. Heathkit only used the gray and black color codes because those were the colors on the remnant of the ribbon cable that was provided, and the rest of it being used here. But I tried to follow the color code here as close as I could without having gray wire, but it doesn't really matter because the instructions just say stick either wire into either hole down here. It doesn't matter since it's AC. And now look at this. I can't put the rear panel on enough for the switches to go through the holes because the back of the power jack hits the rear circuit board. Something has gone awry here. So I've gone back and reread everything in the manual about mounting the power jack and dressing the wires and everything, and nothing says anything about having to fold the leads or the pins down or fold them over. But I found that that's what I had to do in order to get the rear panel up close enough to the rear circuit board for the switches to poke through the holes. You really get the impression that whoever wrote this manual didn't actually build one of these to check that the steps make sense. Starting to assemble the rear panel with its nice black finish, I thought that these stainless steel screws kind of stand out. They're 1/4 inch 632 button heads, and I happen to stock for my own projects the same thing but with a black anodized finish. So I'm going to use those just because I think it'll look better. Up to this point in the assembly, no mention is made of removing the paper protective cover on the annunciator here, as they call it. That's put over there for when you're doing like wave soldering, and then, or not wave soldering, but cleaning of the circuit board using, you know, solvents in a factory environment, so water doesn't get inside of this. And then it's supposed to be removed, and there's actually text on it to the effect that you're supposed to remove it once you have completed cleaning of the circuit board. The instructions don't mention that that's even on here, and maybe the one that they used when they were writing the manual didn't have it, but I think it needs to be removed, or the annunciator sound will be attenuated a lot, so I'm going to remove it. Okay, the back panel has been screwed to the rear circuit board with the anchors in between, set down flat on a table, and gone from slightly loose to tight. Make sure everything's in alignment, and I do a alignment check by making sure all the switches click easily and do not bind. And now I'm probably going to have to tighten the nut on this power jack. It has not instructed me to do it yet. Next up is connecting the display circuit board to the front panel assembly. There is a button cap, 4 plastic spacers, and 4 small screws that are used for that. And it essentially involves the same technique that was used to do the rear panel assembly, putting the screws through the circuit board and into the tapped holes in these anchors, but putting the spacers in for a little extra separation between the front of the displays on the circuit boards and the rear of the front panel. Okay, that's done. That was a little bit tricky. Hard to get the screws through and the washers in the way, all 4 of them at once, when it's a loose fit. I ended up doing 2, 1 on each side, so diagonal. Those are just the ones that didn't fall out immediately. I tried to squeeze the washers into a bit of an oval with the pliers to make them grip the screws a little better, and that worked a little bit, but they mostly wanted to spring back. But eventually I got them all in there. And now the bottom panel, which is a matte finish on one side, and that's the side that has the Heathkit label, including a lot of dust. It's a little better. And then the glossy side, which is internal, and that's the one that has the label with the serial number on it. That gets assembled with the 4 rubber feet screws. That uses these holes that are closest to the front and rear ends, and they go into the bottoms of the anchors in all 4 locations. There's this hook and loop strip, basically a strip of something approximating Velcro, although I don't think it's an actual Velcro product. The instructions confusingly say to refer to figure 2.5 for preparation of the strip, but it's not clear what it's telling you. It certainly says put holes at each end, but then it appears to show it being cut in half, and then it skips several steps and then goes and starts talking about what to do with the hook and loop strip. You know, it says find it in the tools and hardware envelope, but up here it says to prepare it, or at least refer to the that's in the wrong place. It shouldn't be up there. It's in the middle of something else. It should be down here where it's applicable. I don't know what these guys are thinking. It's just bad instructions. Poke something through to make a hole about 1/2 inch from each end of the strip. Now it says refer to 2.5, cut the strip in half. Yeah, so that paragraph up here is just in the wrong place. And now it's been cut in half. And these two 440 by 3/8 screws accompanying lock washers and nuts go through the holes that have been poked in the strips to anchor them to a couple of holes on the bottom panel of the clock. And look at that. One of the holes, I know it's a little hard to see there, but there's a hole right at the tip of my finger, and if you push the ribbon cable down between the boards, it covers up the hole. That doesn't seem quite right. I did orient the rear or the bottom panel so that the battery holes are a bit closer to the front panel than to the rear, and that is per the instructions. Note that the glossy side of the bottom panel faces up. The battery holes are slightly closer to the front than the back. Yep, I've done that. Ensure that the screws do not prevent the ribbon cable from sitting flat against the panel. Push the hook and loop strips down over the protruding screw head or screws. Lower the battery holder down on top of the hook and loop strips toward the bottom panel, ensuring the ribbon cable sits flat neatly underneath it. Both strips have the same type of surface, hooks or loop facing upwards, and each screw shaft comes up through the matching hole in the battery holder. Okay, the battery holder is screwed in, and indeed the ribbon cable gets pinched between the battery holder and the bottom of the case, so it sits up a little higher and cattywampus on there. Not great design, but probably adequate. And the hook and loop strips stick out either side. I believe the idea is that you then curl them over the batteries, or rather over the cells in the battery assembly, just like that, to hold them in place. Next we'll be assembling the case top and two wooden sides. So I'm setting this assembly aside for the moment, and it's pretty clear that some of these 632 by 1/2 inch screws will pass through these laser cut acrylic and probably super glued or thermally welded tabs, or whatever we're calling these, flanges, I don't know, into the holes on the inner sides of the wooden sides. The instructions instruct the builder to use that self-tapping 632 screw that was included in the little plastic baggie to do the job, but since I have some proper taps, I use those to tap all the holes in these wooden sides. Now, the instructions say to put that self-tapping screw in to the wood to make tap holes in it. It says, turn the screw for only 2 revolutions of the screw, no more into each hole, then back it out. Well, I went all the way till the tap bottomed out in there. You know, the hole that's pre-drilled doesn't go all the way through, and that was not sufficient to let the screw go all the way in. As you can see it there, the screw is too long for the dimensions of the material and so on. So I'm guessing that that self-tapping screw might do a better job of going deeper into the hole, because the tap I have is not a can't think of the right word, but the tapping part of the tap, where the threads are, doesn't go all the way to the tip. It's intended to be used going through sheet metal, where you can just go clear through it, not into a blind hole. So I'm going to try the self-tapping screw on this and see if the threads go a little deeper, but 2 turns seems ridiculous. I don't know why that is in the instructions. Okay, even after using the included self-tapping screw, this is as far as the screw will go in. Now let's see if that's enough. By putting it up to here, it just barely but loosely, you know, it's not as snug as it should be. So that little plan of theirs didn't work out quite right. These screws are really a little too long. Alright, that worked after I took off maybe a 1/16 of an inch or so of the screws on my sanding belt, now that they fit in there. Troubleshooting this clock, I noticed that the circuit board X-ray views are done in monochrome. Heathkit never did that. When they had double-sided boards, they used, you know, red and whatever the other color was. Red and gray maybe, but certainly red. So you could tell the difference between the 2 sides of the board and their respective foils. When you do it all monochrome and you put one on top of the other, it's a lot harder to figure out where things go. You know, it's like, this is printed in color. How come the X-ray view can't be printed in color like it should be? Boo! Alright, with the AC wall adapter plugged into the power jack on the rear of the clock, I'm going to turn on my power distribution panel, and we should see the clock come on and start counting from 12 with alternating low battery indicators. I guess that was a firmware revision real quickly. Now to my eyes, those decimal points look just like the color of the 7-segment display. In the camera they look a little different, a little more orange, but that's an issue with the camera, not with the actual LED color. Now one thing I notice here is that because the LEDs are back in there and the light pipe focuses or directs the light forwards, and there's the mask on here, while you can read the 7-segment LEDs pretty far off axis, the light piped ones only really look good from straight on. The diffuser on the moon here seems to have worked, and I triggered it to go to low light mode as I fiddled with the light sensor over here. So that seems to be working so far. I'm going to see if it works with lithium cells in there, even though the voltage on them is a bit lower. But they'll hold up their voltage much better, they'll last a lot longer, and they won't leak. Okay, the cells are in there. I'm going to fold up the hook and loop strap across the top of them, and the low battery display has gone away. So apparently their voltage is sufficient, at least when they're fresh, to be above the minimum threshold. So this half moon here is the, or crescent moon, is the battery indicator, and a 2-second push of the button should toggle that on and off. Oops, I turned on the actual alarm. No, it's the bell icon. Yeah, that's the, it flashes apparently to let you know the alarm's on. Okay. It says it takes 2 seconds for the alarm, the LED behind the bell icon on to off. A chirp audibly confirms the change. So it doesn't take 2 seconds, it's like 3/4 of a second push. Okay. Okay, I'm in a fairly brightly lit place here. I'm going to put my finger over the light sensor and see if it dims or changes. I don't see any difference. Okay, there is a little change. It's not very dramatic. Maybe get it really bright. I'm going to try taking the lights off in the room. However, with the lights really turned off in the room, the display is a pleasantly bright level. It's easily readable, but not glaring at all. And as soon as I turn on my bench light, the display gets bright enough I can read it. When I turn on the room lights, the display is plenty bright, so I think it is working. It's just not enough of a light change, just holding the finger over it, to make much of a dramatic change in brightness. Okay, it says here that a brief front panel button push should cause the bell icon to flash rapidly. Just a tap, I guess. Yeah. That indicates a 10-minute countdown period. Touching it again turns it off. So that's working. Okay, I'm into the final assembly, and it says long push the alarm button if required to light the bell icon. Okay, I've done that. If necessary, change the time to a PM time and 12-hour mode in order to light the moon icon. Well, it's already lit. View the clock display. Determine whether the colon, moon icon, and bell icon LEDs are properly aligned with their translucent mask areas on the front panel. I would say they are. If they are not, the colons or icons may appear partially lit or misshapen. If they are not properly aligned, very gently reach in and nudge them into alignment. I think they're pretty much where they need to be. It's maybe this top colon needs to be raised ever so slightly. But because of the way the LED's soldered in there, I don't think I'm going to be able to move it much. It's just going to bend the shrink tubing and the light pipe, and then it'll just snap back, so I'm going to leave it where it is. So now we'll get into the final assembly of the case. So I've unplugged the AC adapter, and it's in battery power mode now. It's just turning on the display very briefly, ever so often. .47. It is keeping track of seconds. How accurately, I don't know. But it is accumulating time without the need for the synchronization signal from the AC power. So that seems to be okay. Look at this. When I try to put the sides on, the top bows, there's not enough space. That's interesting. I think the holes drilled in the wood are not centered properly, and it's making this narrower than it should be. That's a problem. Yeah, you can see that the holes are not centered, but that's not what's really making this problematic. It's partially that just the way everything comes together here, the sides angle in. It's not very precisely made. I'm not sure, these flanges might be not quite straight, or maybe the wood isn't quite perpendicular on its edge versus its sides. I'm going to have to loosen those screws up a little bit. Yeah, I had to loosen the two screws on each end between the flange of the top panel and the side panels in order for them to not pinch excessively when going down the sides. That was a necessity. So I need to peel off the protective paper here. I'm glad to see that the top is a matte finish. It would be horrible if it was glossy. It would just be dusty, ugly looking all the time. Okay. Let me plug this back in. Okay, it has returned to normal operation. It's a decent looking clock. Really, the wood is what does it. Otherwise, it's not particularly attractive. The light shields around here seem to be doing their job. The icons light up pretty evenly. They're adequately bright. The front panel is way too glossy, shows too much reflections, but in reality, if you're not up close to it, it wouldn't be that bad. The viewing angle's not bad. Again, you're supposed to be using this as an alarm clock, and so presumably it's going to go near your bed or on a dresser or something. So the ultimate product is fairly attractive looking. This edge of plastic here isn't all that great, and this is the same way. It's not horrible, but more mass-produced product probably would have done something about that to cover that up. There's definitely issues with these indicators. Once you get off axis a bit, they are harder to see. But, you know, within a reasonable range of viewing, you can see them all right. There's the beauty shot. I'm going to use my GPS synchronized Nixie tube clock up there, 9:23:22, 23:24, as my time reference for setting this clock. Okay, I'm going to change the clock mode. Since I can't see the rear at the moment, the 4 buttons on the rear from right to left are the mode button and a set button associated with mode, and the hours, minutes, second button and a set button next to that. So I think, without reading the instructions, that for setting the clock you can toggle in a cyclic fashion between hours, minutes, and seconds, and then set whichever one you've selected, or change it to an appropriate number for hours or minutes or seconds. And then the mode, you'd select which mode you want to be in, and then set that with the button. I'm pretty sure that's the way it's going to work. So it says push the mode button repeatedly to display each successive clock function on the mode menu. The mode button does not select or execute the displayed function. To perform the displayed function, push the select button next to the mode button. Notice that the displayed text tells you the action you will be taking if you push the select button. Okay, so I'll reach back around there and find the first button. Set alarm, okay. Push it again, alarm off. Push it again, set 24-hour mode. Select low. Oh, that is, oh, CO. After a short period of time, about half a minute, if you do not select a function or press mode again, it'll return to the normal time like it's done here. Setting the current time. Set the clock function to set CL. Cal 60 Hertz, Cal 50 Hertz, set CL, okay, set clock. Now I can go over here and change what I want to change. Oh, I have to push the set button first. Okay, now it's set to hours, minutes, and seconds. If I can find that button, I can change hours, minutes, and seconds. But I need to change to the appropriate time mode first. So I'm going to go back here and push the mode again. Sync. It's supposed to be checking sync. Okay. What was I trying to do? I've got to go to the appropriate mode. So select that. And what do I do? Alright. Let me go back to set clock. Okay. So it's in 12 mode. And current time is 9:30. But it's going to be 9:31 here shortly. So I gotta... So it's definitely in 24-hour mode. So I'm going to... Oops. It should be 21. Okay. Oops. There we go. Button is really sensitive. I'm going to go to 31. If I hold it down, it scrolls fast. Okay. And seconds. Boy, it definitely bounces off what you want. This is not, these buttons are not well debounced in software. So it's coming up on 40, so actually I'm going to go up to 50. Okay, yep, there we go. Okay, I guess I have to push the mode button to get out of there. Okay, so pushing the mode button once more goes into sync mode. Sync keeps the clock time frozen until you release it. Oh, I see. So it's holding it at 51 until I release it by pushing the mode switch again. So if I didn't use it correctly, I need to go back and set again. So I'll go back and set clock. The hour is good. It's the seconds. I'm up to 33 already, so I gotta go and set that to 30. Oops. 30. Okay, 34 will work. And set that to 0. And now I go push the mode button. And now it'll just hold that time, 21:34. And I'm waiting here. I have about another 30 seconds to go while the air compressor is running down in the basement below me. And as soon as another 20 seconds goes up, I'll push the mode button again to release the sync. I don't think the sync is, I would call it hold. Sync makes it sound like it's synchronizing with something, and that's sort of what's happening. It's just, it seems to me the wording is a little odd. Okay. Get the old finger on the button. Boom. Okay. So 9:34. This is right what my Nixie tube clock said. Okay, I'm going to get it out of 24-hour mode. I'm going to push the mode button until I get to set. Oops. Okay, now it says set 12. And I push the set button. Okay, now it's switched over to saying 9:36, which is what it should be saying. It says when you're in 12-hour display mode, the clock's moon is what indicates that it's PM. So that makes sense. It's half a crescent moon for PM. Okay? Setting the alarm time, wake up time. The alarm function menu set AL allows you to set the wake up alarm time. Use the mode button to select set AL, and I push set, and just like setting the time, I'm going to set this for 9:40. So okay. Nine, and the indicator's on, so I guess that means PM. Let's go around. Yep, now it thinks it's AM. PM indicator came back on, so 9, and I want to set it for 9:40. So actually I don't wait that long. It's going to be set to 39. Okay. Use the mode button to accept the alarm time. And now I have to change it to set alarm on. Okay. Now I have to push this button. 2 seconds, so you can see the alarm is on. Pushing it briefly, you briefly see it set for 39. So here in just about 15 seconds the alarm should go off. We'll hear how loud it is. Seriously? That's the wimpiest alarm I've ever heard. Okay, I've turned the alarm off. Have to do something about that alarm loudness. If you don't like the colons winking and blinking, the set CO allows you to change that. Press mode button until you get to set CO. That's it. Although from where I'm standing, looking down at it, looks like it says LO. LO. Then select to choose it. And there's the flashing colon. You can get it to be off, on, blink once per second. The select button. So that's off. That's on steady. That's on flashing. I definitely want them to be on, but I don't want them flashing. That's just annoying. Okay, then mode button cycles back to the current time. Here's where you can do all that junk. Okay. (9:40:58) is what the other clock says. So this is a couple seconds off. I may not have been that precise in my my button pushes when setting it. Alright, accuracy calibration. Calibrate mode Cal 60 or Cal 50 allows you to calibrate the internal microprocessor using your alternating current electrical mains line frequency. Calibrate mode generally will bring the internal microprocessor clock to within approximately 0.5% of the represented line frequency or better. Calibrate does not set the clock time, it adjusts the clock's unique electronics. There's no unique electronics in this thing. What a bunch of shit. To be as accurate as possible for your local electrical and operating environment. It's like, no. Maybe in third world countries, but around here, if you have a AC synchronized clock, it goes forever within a very small margin of the correct time, as they're constantly monitoring and adjusting so that overall the time of such devices remains accurate. So that's what the other two resistors in the kit are for, to make the alarm quieter. It's already super quiet. Yeah, this would not make an effective alarm clock. So it's already at its loudest, in other words. And that's just lame. That's a horrible alarm clock if that's as loud as it gets. Shame on you, Heathkit. Now the multi-function alarm timer front panel buttons and icons. Okay, to stop the alarm from sounding. If the alarm is enabled when the clock time is the same as the stored wake-up time, the annunciator will warble. It is designed to be unforgiving, in other words, to wake you, and continues sounding until you stop it. To stop the alarm from sounding, simply push the front panel alarm button. This immediately puts the clock into a snooze mode. Now the alarm will wait 10 minutes and ring again. When it sounds again, a single push of the snooze will snooze for another 10 minutes. No limit to how many times you can snooze. To disable the snooze function, touch the alarm button briefly while the alarm is not sounding. The clock bell icon quick flashing will cease, thereby confirming that the snooze is deactivated. Well, it's not doing anything now. Alarm enable disable. A long press lets you turn the alarm on, turn it off. And when you turn it on, it should briefly flash the time setting. Yep. Okay. The alarm has a 24-hour period. If set in 12-hour mode, it also remembers AM or PM setting. For example, if the present time is 9 AM, setting the alarm for 7 AM causes the alarm to sound the next morning, 22 hours, not 10 hours later. Timer enable disable. There's a built-in 10-minute convenience timer. The timer is independent of the daily wake-up alarm. You can activate the timer anytime the current time is displayed and the annunciator is not sounding. The timer can be very useful as a reminder, to remind you to leave for an appointment, to check on cooking food, blah 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 blah. To start the 10-minute timer, simply touch the alarm button. It's already doing that. The bell icon will start to flash rapidly and will continue to flash for the 10-minute period. After 10 minutes have elapsed, the annunciator will sound. Once sounding, the annunciator will continue to sound until you stop it. A single brief button press stops the sound and resets the timer for another 10-minute period. A short press of the alarm button whenever the annunciator is not sounding turns off the timer. Another short press starts the 10-minute timer again. The snooze function also uses the 10-minute timer. The clock should be able to survive a period of up to 10 to 30 days and keep accurate time with no power applied, depending on the type and health of your clock's batteries. When external AC electrical power is available, the current consumption of the batteries is insignificant, and the battery life should approach the in-service shelf life of the batteries, typically a year. That's for alkalines. You can adjust the display brightness. There are bright and dim LED levels. You can adjust the maximum brightness level by changing a resistor. Okay, but not using any controls here. So, I mean, the controls are fairly simple and logical. I can't really fault them for that. I'm just going to let this thing sit away here and cook and see if it stays within a few seconds of the correct time, you know, sometime tomorrow. Well, I was in the other room and I heard this noise. I couldn't figure out what it was. Barely could hear it. And that's the 10-minute timer going off. I mean, it was audible, but I'm not sure that would wake me up. Maybe. But it's pretty wimpy. Yep. Oh, it's still on, so I gotta... Yep, there we go. Just have to do whatever you need to do with the button to make it stop flashing quickly like that. Boy, those colon LEDs really look like they're a different color in the camera, but to my eye they're exactly the same color. That's weird. They have these, I don't know what it is about the CCD pickups on digital cameras, but they all seem to have that issue with detecting red properly, at least certain wavelengths of red. Alright, it's the next day, about 12 hours later. Well, yeah, not quite 12 hours, but a number of hours later, overnight anyway. And, yeah, it's an okay clock. It looks decent. The display's okay. It's a little primitive with the really abrupt masking. You know, a lot of companies use more sophisticated masking on production clocks, but maybe that was beyond what they could do with these, 3M or whatever they are, front panels. I've already outlined issues I had with the instructions and how things went together. Not insurmountable ones, although, like I said, I had to furnish some parts by myself or on my own. It's just about 3 weeks now since I started working on the kit and noticed the missing parts. And I still do not have a response from Heathkit. I wonder if they're still in business, actually, with such slow response, if any response comes. I don't anticipate it'll be anytime soon. Okay, so the clock has no discernible warmth on it. It apparently is able to get rid of any heat from the heat sink or other components adequately. The power pack is just ever so slightly warm. And yeah, it's, you know, it's an okay clock. Is it worth the really high price one has to pay for it? Not if you just want a clock. If you really want a Heathkit building experience without buying, you know, spending $1,000 for an unbuilt Heathkit off of eBay or something, this is probably about the best you're going to get. There are some fit and finish issues. On this side, the wood sticks out above the top. On this side, it doesn't. You know, just lack of accuracy in some of the parts. Again, something you would not see in a production clock, and frankly, you wouldn't see things quite like this on the original Heathkits either. They would have been, you know, their sheet metal was usually very precisely stamped, and other wood parts were better done than this. Still, some effort went into it. You know, I don't know. I wish I had a better idea how viable the Heathkit company is. You know, obviously they shipped something that I ordered on their website. That happened, but as far as support, service, non-existent as far as I can tell. The clock is working. We actually had thunderstorms go through last night. First time it's rained in almost a month. And there was a brief power outage. I think it probably lasted about 5 minutes. The clock, as I said earlier, seems to have held its time. So, you know, I don't know how it would do on a long-term power outage because I haven't done any calibration or attempted any calibration. But, you know, it's working. The only real beef I have functionally on this clock is the extremely anemic alarm buzzer. That's just inexcusably soft. I'm not even going to bother contacting Heathkit about it because they haven't responded to my earlier inquiry. I doubt that I have a defective buzzer, and as I pointed out, I did remove the water seal on it, so it's not because of that. I don't think I adequately or properly covered the way the clock is set on this. I mean, the internal clock, that is, not the time setting. So, what's actually going on there, according to the circuit description and further study on my part, is obviously it uses the line frequency to keep track of the time. It gets a tick, if you will, by dividing down the frequency. It monitors the line frequency through the power cord, and it divides that down by either 50 or 60, depending on whether you've selected 50 or 60 hertz mode. And from there, it gets 1 tick every second, and that's what it uses as the master clock signal. There's also the internal clock of the microprocessor, which is not controlled by an external crystal. I'm not sure what they use internally, but I don't think it's crystal based. So what Heathkit has here is a way to adjust in firmware a correction factor for the internal clock of the microprocessor when it's running on batteries. And it does that by taking a look at the line frequency properly set for 50 or 60 hertz, and uses that as a reference to compare the internal clock of the processor to, and based on that it makes an adjustment in firmware. So anytime it's running on battery, it knows how much to correct the time base from the processor's internal clock so that it's reasonably accurate. So I'm going to go ahead and do that now. I may have done it before by accident. So it's just a matter of selecting the the line frequency, and in the course of doing that, it does a calibration, and it's also supposed to mess up the time setting. So I'm going to go here and push the mode button, and I'm going to go to calibrate 60 and then push the select button. And apparently it's a correction factor of 4, whatever that is, and it's set the time to the wrong time. Oh no, wait, 12:01:30. It's really close. It did seem to maintain the time pretty well, even though the manual said it wouldn't. So I'm going to resynchronize this puppy now. I'm going to go to time set in the mode, set alarm, set 24-hour mode, set that, set clock, okay, and it's indicating the PM there, so it is 12 p.m. here. It's just afternoon, so I can go and push the set for that. I boogered it up. I shouldn't have clicked that one. Okay, 12, and then move to minutes, and it's going to be coming up on 4 here soon, so I'll set that to 4. And the switches definitely need to be debounced better. Just simple clear clicks on my part, sometimes it advances 2 or 3 numbers. That's not very good. You know, people have figured this out on digital clocks for ages, and Heathkit hasn't figured it out yet. Okay, so, and then we go to seconds, and I'm going to set that to 0, and then I'm going to push the hours, minutes, seconds again. Okay, so now I go back and push the mode button again. Well, I'm going to just review what I've got here. So 12 p.m. 04. Okay. I'm going to push the mode button and it's synced. And we're there. I was a little slow. It's off by about 3 seconds. I have to look back over my shoulder to see the other clock, and so pretty close. 12:04. Alright, so I've made sure the internal clock is calibrated. Alright, I'd started to do an overview of the manual earlier and then kind of aborted it, so I'm gonna just go over it very quickly here and make sure I've covered the whole manual. So again, it's got a nice plastic front on it. That's a nice quality mark. I do like the spiral binding. That obviously allows them to print in smaller batches and have more flexibility in changing out the pages. I note the copyright 2016, so this design certainly goes back that far, if not further back. It looks like it might have been revised as recently as 2020, but with the errata and stuff that's in here, I really doubt they made a lot of changes, but who knows. It does say revision 2.1 blah 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 blah. So pretty decent table of contents. Introduction. I'm going to restate what was probably done earlier The Heathkit model GC-1006 Most Reliable Clock, trademark, is a full-featured, thoughtfully designed alarm clock. As a kit you assemble, it is designed to help you experience and learn about the fundamentals of electronic equipment. And that is only true to the sense that the manual makes very little effort to actually teach you anything, but you do maybe learn some terminology and what components look like and things like that. That was always a promise that Heathkit made. You know, you learn some electronics, but it's not like they're teaching you theory or anything. It offers attractive modern styling fashioned after the very popular Heathkit GC-1005 clock, which was our very first and most popular clock in 1974. Yeah, I know that these guys bought the trademark to Heathkit, but everybody knows it's not the original company we're dealing with here, so I don't know. Some of the subterfuge here is a little blatant. The Heathkit model GC-1006 Most Reliable Clock, trademark, has many attractive features, including the 12/24-hour display, which every clock has, AM/PM wake-up alarm with snooze feature, which every clock has, custom-designed internationally recognizable icon indicators, okay, a 6-digit easy-to-read display. Well, there's nothing easier to read about this than any other digital display on anything ever made. A backup power source with internal backup timekeeping, okay, which every clock pretty much has. An auto-dimming feature that automatically adjusts the display to ambient light level, which pretty much every digital clock has. An instant one-touch 10-minute recurring timer function, okay, that's probably unique. And a multi-function front panel alarm button that provides all of the clock's day-to-day features using a single button. I'm not sure that's really a great thing, but okay, a lot of clocks do something similar. The heart of the clock is an Atmel microprocessor with custom Heathkit firmware. Okay, great. The GC-1006 will continue to operate when mains power fails, and its patent-pending design has very low power requirements. Okay, well, any plug-in digital alarm clock that's been made in the last few decades pretty much does that. And there's nothing patentable about having battery backup on a clock. There just isn't. I doubt they got that patent, unless the patent office was really sleeping that day, if they even filed the patent, or if it's just hyperbole here. In typical use with the superior quality fresh batteries, it will operate superior quality fresh batteries. Okay, now it can't just be regular batteries, they have to be superior quality fresh batteries. It will operate for up to a month with no external power, continuing to keep time and provide an operational alarm. Okay. When power is restored, the GC-1006 Most Reliable Clock, trademark, knows and resumes display of the proper time, subject only to a small amount of drift. And that is, of course, because they're not synchronizing to the AC line during power outages. A custom calibration feature lets you synchronize your clock to your local electric power mains frequency for best possible accuracy. And that may be unique to this. I don't think I've seen or heard about that on any other clock. The GC-1006 has a special cabinet custom designed to permit easy construction and learning while you build your clock. Really? What are you going to learn? Its state-of-the-art mechanical design make it both educational and attractive. Again, they're pushing the educational button too many times here. It's kind of nonsensical. Competing easily in quality with commercial electronics appliances. Well, okay, probably. When your kit is finished, you will have a beautiful, functional, elegant alarm clock for daily use that you will be proud to display to your family and friends. Especially if you're a serious geek, which is probably most people who'd be building this kit. Fair enough. Okay. Getting started unpacking instructions, the unpacking list. Then copying text and I don't know how completely they copied text. Certainly a lot of the diagrams are from the old Heathkit manuals. Certainly that one is. These are straight out of the old Heathkit manuals. Tools that you need, tools that are included. The only two tools that are included besides some self-tapping screws are a couple of hex Allen wrenches. Pretty much a repeat of the traditional inserting and soldering components from the old Heathkit manuals. Another page of that. Making your work look professional. And again, some of these look like old Heathkit diagrams like this. Some of these are from other sources, I think. I don't think they drew a whole lot of new stuff in this area. This is straight off of old Heathkit manuals. Parts list. Parts list. Parts identification drawings. And they put the serial number across there, which seems totally unnecessary and just distracting. This is the personal product page, or the page that mentions the personal product page. More diagrams. So these are not quite up to the original Heathkit standards when it comes to illustration, but they're good enough to serve the purpose. Finally, we get to step-by-step assembly. Again, there's some old diagrams that are copied from before. This is done very much like the original Heathkit circuit board assembly diagrams, so good on them. They're fairly clear with it for the most part. So diagrams are pretty decent in this regard. They do the job. I'm not sure how many of these have been glommed onto from older manuals and how much they have drawn originally. The diagrams for assembly of the light pipes and so on, that's pretty good. The diagrams for the light shield are good, except that for some reason they've drawn it looking like it's cut down the side, which it isn't. They may have felt they needed to do that to show all the detail, and that might be true, but like this is just confusing. That's not the way it looks. I kept looking at that and said, what are they trying to get me to do there? I just finally figured it out sort of on my own. Yeah, that's all good. The way they show the preparation of the ribbon cable's good enough. Pretty close to the way Heathkit would have done it in the past. Except for things I've already mentioned where they start getting a little sloppier with the text and inconsistent use of terminology and some other issues. It's still pretty reasonable. More mechanical assembly diagrams are adequate here. This is all well and good. Good enough quality on these drawings. They do the job. No real complaints on the illustrations here. It's fine. There is some inconsistency on, I can't think of the word I want, but for example, these are drawn on one plane angle of view, and this is drawn on another angle. So a little bit of drafting issues there, but nothing significant. That's all okay. Diagrams are fine. Now we get into operation. It has a picture of the clock, figure 1, which serves no real purpose because you have the clock in front of you and there's nothing on here that says, you know, look at this point. It's just a picture of the clock. This is okay. Diagram of the rear panel. And I should note, if I haven't already, that the quality of the paper on here is quite good. It's a nice, thick, high-quality paper. They didn't chintz out on this too much, I don't think. The instructions for setting the time are reasonably adequate, I should say. There's a flow chart for clock modes and functions, which could come in handy. Some of the descriptions on here regarding things like the colon blinking and the accuracy calibration, I read through a few times and I wasn't absolutely sure what they were saying. Like they're trying to make it sound cuter than it really is, and I don't know. It's not horrible, it just could have been better. They talk about how to reduce the volume of the speaker by increasing the series resistor, but at least on mine it starts out really soft from the get-go. So, battery life should survive a period of up to 10 to 30 days. There's a big difference. At least that pretty much agrees with up to a month that it has in the product description. They talk about adjusting the display brightness. Care of your clock. It says clean with a simple dry cloth to remove fingerprints and smudges. Yeah, but if you got greasy fingerprints on it, just rubbing it with a dry cloth isn't going to do the trick, and you might scratch some of the acrylic. You probably are better off using a very mild cleaning product, spray cleaner, sprayed onto a cloth and then wiping it down, but okay. Theory of operation. There's a very vague overview and a block diagram. It's okay. Essentially a one-page circuit description, which is very vague, focuses on some things, pretty much ignores other things. There were some traditional Heathkit manuals that were similarly vague, and other ones that really went into the weeds trying to describe the circuit theory. This falls in the former category. You're not going to learn very much from this the way they did it. They could have more consistently covered things. It just felt like it's an obligatory thing, like, well, we have to check this box, and we don't know how much detail we want to go into, so let's sort of do it halfway. Specifications. Mode, 12 or 24-hour mode user. Selectable reliability, 4 weeks nominal. Continuous operation in power fail mode using Duracell Quantum AA cells. 3 weeks continuous operation power fail mode using Duracell Copper Top AA cells. Negligible drift, it's line frequency dependent and normal mains power mode. 0.5 seconds per day typical. And it really shouldn't drift. If you're in, most of Europe, if you're in North America, places with a good solid power grid, they are really good about, yes, the frequency will shift slightly on a day-to-day basis, but they keep track of that and make small adjustments to try to even it out over time. So AC synchronized clocks are usually pretty darn good. Not as good as GPS or atomic clock, but pretty darn good. So you shouldn't have to worry too much about drift unless you're in some part of the world where you've got lower quality power. Front panel, blah blah blah. Power jack, 4 clearly labeled controls, annunciator, size, They say it weighs 1 pound or 0.5 kilograms, nominal with batteries included inside. Recommendation on Duracell Quantum. Included all kit parts. That shouldn't be in the specifications. I don't know. Compliance. Lead-free UL power adapter. Patent pending. Why does patent pending under compliance? And I don't know. It's like they're really trying hard here to make it look like they've got something unique that nobody else has ever thought of in terms of how this thing works. EMI RFI safety. No switching power supply. No mains line voltage in the box. Circuit board x-ray views, which are okay, except for, again, they should have been printed in color. I mean, they're printing this thing page by page, so they could have printed that in color. There are color printers. Circuit board voltages, that's fine. That's typical for Heathkit. Parts identification chart. It's okay. It's kind of a haphazard thing. You know, this one has a schematic diagram. None of the other ones do. It's kind of a hodgepodge, but it's okay. The schematic, it didn't really need to say Heathkit across it when it says Heathkit right there with the trademark copyright symbol. Really, so it just makes it harder to read with a, it's like, I don't know, kind of silly. In case of difficulty, half a page. Troubleshooting chart, I read through it, it's reasonable. Doesn't cover everything. And then that's the back page. I just have some paperwork stuck in here. Alright, this is the schematic from the Heathkit manual. Some of the text is really hard to read, especially around the displays. It's really tiny. That's bad draftsmanship. A rule of good drafting is that you find the smallest size font that can reliably be read on the size of drawing that you're expecting it to be. So Heathkit did not produce this as, say, 11 by 17. It's on an 8.5 by 11 sheet of paper in the manual, and it doesn't even take up the whole page. There's a lot of wasted white space around it. So they should have done like a quick mock-up of, you know, here's how big the schematic can be when it's produced, and we need to make sure that at that size all the text is legible, and then finish the drawing using only that size text and adjusting everything else around it. That's a good way to do it. They did not do that. Anyway, so this is hard to read, so get rid of it. I made 2 sketches, and I didn't plan on shooting video of these. I just did them for my own circuit study, but I'll still use them anyhow. So I've confirmed that the AC power adapter, or wall wart, is in fact just a 9-volt AC secondary power transformer. Nothing more to it than that. It comes in through the barrel connector on the rear. One side of that's connected to ground. The other side comes in here. And it's half-wave rectified and filtered by the main filter capacitor and then a smaller capacitor in parallel with it. If you were to measure this with a DC voltmeter, a high impedance DC voltmeter, or a digital multimeter or something, you'd get around 12 volts. And that's just the peak voltage not being loaded that much and then filtered again with not much load. If there is power coming in through here, then we have these 2 diodes that couple the 2 power sources together. The other power source being the battery. It has 6 cells and assuming alkaline cells are in it, that's going to be about 9 volts. So it won't be more than 9 volts. If you've got 12 volts up here, then this diode will be forward biased and will conduct, and even with the diode drop, it'll still be more than 9 volt. So this diode will be reverse biased and will not conduct. Therefore the battery is just sitting there and is not being drained by much. However, it is being drained slowly by these resistors here. On the other hand, okay, so then the power could feed this way if there is no power here. So if the power fails, the AC power goes away, then you have the 9 volts here minus the 0.6 volt drop of the diode here, which is more than 0 over here, so this diode is certainly reverse biased. Therefore the power capacitor is not part of the battery circuit. Either way, you get somewhere around 11 and a fraction volts on AC power, or 8 and a fraction volts on battery power. And that's applied to the 7805, and all it needs to have is 7 volts on the input to work properly, 7 volts or more. It has a couple small capacitors on it to make sure it's stable, and the result is a regulated 5 volts that is represented on my sketches by this up pointing arrow. This raw, unregulated voltage here is used to power the speaker. It has a 10 ohm resistor which you can adjust if you think the speaker's too loud. You can make a larger resistor in here instead of the little 10 ohm one and thereby attenuate the volume of the speaker. So as I've determined, even with the low 10 ohm resistor here, this speaker puts out a very paltry volume level. It has a freewheeling diode across it, which you would have if you expected this to be an inductive device, which I don't think it is. I think it's probably just piezo, but I'm not really sure what's in there. And there's a path to ground through this transistor, which is controlled via a signal from the microprocessor. The other thing that this raw, unregulated voltage is used for is through this voltage divider. It's a 10K over 1K, and that gives you a power sense. So the microprocessor monitors this and can tell when there's no power. It seems kind of odd because if there's no power here, then there's probably no power here, and the microprocessor won't even be running. But apparently there's some mode where this is useful information. And they may be using this, they're using this as an analog signal, and let's say you're running on batteries and the voltage gets lower, or you've got low voltage coming here, and this voltage here, once divided down, is below a certain threshold. You might still have just barely enough to get the regulator to work, and thereby get 5 volts, so the microprocessor would be running, but yet the voltage here is lower than expected, and it would be sensed here and monitored through the analog input of the microprocessor, and can say, hey, wait a minute, I'm expecting, no lower than about, 8 volts or something there, and it's only 7.5 volts. That indicates something is going wrong with the power source, and it can use this to blank the display, or at least go into a mode where it only turns on the display dimly every few seconds in just a brief pulse. So I think that's how that's being used. It doesn't say so in the manual exactly, but that's what I'm deducing. Okay, the battery again is monitored irrespective of anything else around here, and that's also fed into the microprocessor, and it's looking for a certain minimum voltage here. Otherwise it indicates low battery on the display. The raw AC voltage from the power adapter, it goes through a 10K resistor and then a 5.1 volt Zener diode. And this does two things. First off is on the negative half cycle of the AC wave, this prevents the signal here from being minus or negative of 0 volts by more than a fraction of a volt. And on the positive half cycle, it clamps the voltage to about 5 volts. So you end up with it's not a square wave, but you have a squared off half of a sine wave that ends up looking kind of trapezoidal like that, between approximately 0 volts and approximately 5 volts. And that's an adequate signal to be going in as the 50 or 60 hertz line frequency check. And I should mention here that the manual and the other documentation is a little confusing in this regard. Some places it seems to say one thing, other places it seems to say something else. But I'm coming away with the idea that you don't actually set the 50-60 hertz. That it can auto-detect that by comparing it with the microprocessor's internal clock and then just using whichever one it is and dividing down by 50 or dividing down by 60 to get a 1 second tick for the master clock. So I could see where it would be auto-detecting that. But then you have to select either 50 or 60 hertz when you're doing a line calibrate. So that's a place where you need to be more specific about it. Anyway, so there's that. There's also a light detector, LDR, and this has a resistance of around 2 mega ohms if it's dark. And with, say, a typical amount of light or a normal amount of ambient light for a room, just a rough estimate of what that would be, the resistance drops down to around 25K. And that's in a voltage divider with a 10K resistor off of 5 volts. So you get a different voltage here depending on how light or dark it is in the room, and that's read through an analog input of the microprocessor. So with all those signals here, here's the microprocessor, and they're really not using any pin for more than one thing. So PB0, PB1, and PB2 are providing the load, the digital input, and the clock signals for the serial data being sent to the display IC. So that's how it communicates with the display. And then PB3 is used only by this, I guess it's a programming connector, which there isn't actually one on the board, but there's a place for it. PA0, and again, these pins are all programmable to be inputs or outputs or analog or digital. And they've been programmed by the firmware that Heathkit wrote to act appropriately for this circuit. So PA0 again does that, and it also comes up here, and that's monitoring the power sense. PA1 monitors 2 of the push buttons on the rear. That's actually the hours, minutes, seconds button and the set button next to it. It's a voltage divider between 5 volts and ground, 3 10K resistors. So, and it's being monitored here. So if you don't have any buttons pushed, you have 1/3 of 5 volts. So, 1.65, 1.67, whatever is what the voltage would be here with no buttons pushed. Then if you push this button, it shorts this top resistor out, and the voltage divider just becomes a 50-50 divider with these two 10K resistors. So with this button pushed, you'd expect to see half the power supply, or 2.5 volts. If you push the bottom button, now this resistor is shorted out, and therefore this point is dragged down to 0 volts. So by measuring the voltage via an analog input on the microprocessor, it can tell which combination of these buttons you've pushed. Likewise, the mode button and the select button are monitored via their two switches and another resistor voltage divider. And those two signals come into PA1 and PA2. PA3 is where it's measuring that trapezoidal signal at line frequency. So that's an input. I guess I could go through here and mark some of these things, but I'm not going to bother at this time as for which one's an input, which one's an output. Okay, we already did PA3. PA4 is what's monitoring the battery voltage, so that's an input. PA5 is monitoring the battery voltage. PA4 is what's driving the transistor to operate the speaker. And I believe that this is not a beeper, it's just a small speaker. So any waveform that the speaker's reacting to is being generated by the microprocessor. It's not just telling it to turn on and off, it's actually sending it a frequency. PA5, already did PA5. PA6 monitors the alarm button on the front panel. Now this input has a programmable pull-up inside of it, so it doesn't need a separate one on the circuit external to the processor. So this is normally sitting at 5 volts, and when you push the button it pulls it to 0 volts, and therefore it can tell if you push the button or not. PA7 goes over here to the voltage divider that's monitoring the ambient light in the room. Some of the pins on here are also used for some purpose by going to this place where a connector can be put on. Already talked about that a little bit. So that's how the microprocessor interfaces with everything, and how all these little peripheral circuits operate. Now let's take a quick look at the display. So this is on the display board. First off, this is a MAX 7219 IC. It's designed to control 7-segment displays or bar graphs, or just simply arrays of discrete LEDs under control of a microprocessor, but in a very simple way that offloads most of the work from the microprocessor. So all the processor has to do is say, well, you know, it's this time, therefore I need 2 digits for hour, 2 digits for minute, 2 digits for seconds, and that's just 6 digits of information. It sends that serially over the digital input line and clocked by the signal that the controller is generating, and that causes this chip to read this into memory locations, and it has 8 memory locations of 8 bits each. So these 4 digits on this clock are using up 6 of those memory locations to store the data. Now that that data is stored here, this chip just takes it and runs with it. The processor doesn't have to do any more work. It's sent the information that it wants to be displayed, and this IC takes it out of its internal memory, multiplexes it, decodes it if necessary. For example, the digit information is sent as BCD or binary coded decimal, and this chip has the ability to decode that, as well as several other formats. Or you can just, if you're not sending something that's numerical, for example, segments in a bar graph, or discrete LEDs for some sort of annunciator or panel graphic or whatever, in that case BCD wouldn't make any sense. So you can tell it to not decode as BCD, and I think it also can decode a couple other formats that might be of use. You just tell it which one you're using and it decodes it as required. And it ends up with segment and digit drivers, and this is, by the way, set up for common cathode displays. So for each digit, the cathode of all the LEDs is common, and I've shown those along the bottom of each display. So again, all the segment information, that's 7 segments, A, B, C, D, E, F, G, and the decimal point, are sent out as current limited and controlled current coming out. It goes through the LEDs in the display and then returns via the common cathode and comes into one of the digit inputs. These sync current. Only one of these can be turned on at a time, so only one digit's worth of information is actually illuminating at a time, and it relies on the human's persistence of vision to make it seem like they're all on at the same time. That's true for pretty much, well, for any multiplex display. We're not using 2 of the digits because this is only a 6-digit display, not an 8 that the chip is capable of. Now, the brightness here is handled in 2 ways. You can program brightness with an analog input, and that's done in this case with a resistor from 5 volts through a 10K resistor and into the I set or current set. So that's controlling the maximum current that this will allow to be sourced out of these pins, and of course sunk back into these pins. But that's not the only way to adjust the brightness. So we've established the maximum current here, and then through software, by telling this chip how bright to make the displays, it determines how long of a pulse it should be given during the multiplexing to illuminate each LED. And by pulse width modulating it, for a narrower pulse it'll be dimmer or seem to be dimmer to the eye, even though when it's on it's really the same brightness. But the persistence of vision of the human eye will make it seem dimmer if it's a narrower pulse or brighter if it's a longer pulse. So that's all built into the work that this IC does. Now, there are 6 discrete LEDs on here. 1 for PM, 1 for alarm, 2 for the colon here, 2 for the colon here. And they are all running into the source for the decimal points. So that means the microprocessor has to be keeping in mind, if you will, not only the numeric values going here, but when this LED should be on, this one should be, when these should be on or off or blinking, and thereby turning the decimal point information on and off appropriately. And then these return to different segments. So the PM LED returns to the digit 5. In other words, this LED seems to be treated as the digit 5 decimal point. The alarm LED is treated as the digit 4 decimal point, and so on for the colon LEDs. It's digit 1, 2, 3, 4, 5, 6. Or actually, the digits start with 0, so it's 0, 1, 2, 3, 4, 5. And that's really all there is to that.